explain force. So, first of all, let me explain force. Force is push or pull. Like when a bowler throws a ball, he is throwing it. That means a push. And when the batter hits the ball, it's also a push. But when we mean pull, pull is like catching the ball. Like the ball comes, we don't apply force to it. Its direction will change. So we will just get it and pull it. So that's called pulling. And when you close a door, it's also known as pulling. So glass doors are opened as push or pull. See, this is push. Let me just example it with a table. So this is known as a push, means applying force away from you, and this is pull, applying a force to your direction, means closer to you. But there is also one more property of force. It's friction. See, when I was moving the chair, you saw there was a tiny bit of time which I took to move the chair, because the chair had static friction. It's one of the most highest frictions. So when you saw me push or pull the table, you saw there was a tiny bit of time it took me to push or pull the table, because it had static friction, the highest friction of all. Now here's a heavy bag and it has a lot of weight. If I take it on it, then does it take some time for me to push it. But the static friction is very low here, because this table has rollers. So the lowest friction is rolling friction, and the medium friction is sliding friction, and the highest friction is static friction. So now you know friction is a force. Now let's just take what force can do. It can change the direction of a moving object. It can just take a stationary object. Let's take a stationary imaginary object. If I punch it very hard, then it goes away very fast. But it was static. I overwhelmed the static friction and it sent on motion. So we took from static to moving, means it can set an object into motion when it's stationary. And also we can stop it by force. Look, a football player kicked the ball and the ball was rushing to the goal, but the goalkeeper applied force and stopped the ball from goaling. So this is from a stationary object to setting it into motion, and this is to a motionful object, means an object with motion, which is moving object, to a stationary object. And also it can also change the shape and size of an object. Like a truck was like this, the truck was, and someone threw a huge boulder, so the truck cracked, so it changed its shape, and it also, the truck also looks smaller now. What I meant by changing the direction of some moving object is an example of cricket. The bowler throws the ball with a humongous amount of pressure. It changes a stationary object into an object with motion. And after that, the batsman didn't want to just lose, so he didn't want to break the wickets and lose from the bowling team. So he got his bat and just applied enough amount of pressure to change the ball's direction. So it's with a few steps. He applied enough force to stop the. See, if you have played cricket and hit a ball, there has been a small moment where the ball has stopped, and when you fly, when you take the fling motion, like this was in the, okay. So the ball is coming. You got the bat right over here, and you stop the ball at 90 degree. After that you fling the ball. So this happens like this, but the ball stopped from here and we fling the ball to there. So it's in two steps, but it can change the direction of a moving object. It can change the shape and size of an object, and also it can set an object into motion or stop a moving object. So here's an example of a force can change the speed of an object. See, someone is driving a car and he steps on the accelerator very hard, and the car just goes off with more speed. So it's a moving car and the driver wants to stop it. So he presses on the brakes and the car stops because it applied force on the moving tires, which slowed down the tires, thus slowing down the car. So it can just affect its speed too. May I get questions?
Now here are some questions for you related to force chapter. 4 options are given here. I will read only questions. And
how many questions can I? Can I
there
only
are
get 5 questions for the video?
There are 10 questions.
Can I only get 5 questions for the video?
No, there are 10 questions and they are very simple questions.
You can just take 20.
Okay, thank you. Choose the correct option. And question number 1 is, which of the following is not an effect of force? Option A force can change the speed of a moving object. Option B, a force can change the direction of a moving object. Option C, a force can change the composition of a moving object. Option D, a force can change the shape and size of an object.
What's option C?
Option C, a force can change the composition of a moving object.
It cannot change the composition. Okay. What is option A and B?
Yes. Option A force can change the speed of a moving object.
Okay.
Option B, a force can change the direction of a moving object.
So it's definitely C.
C, okay. Question second, which of the following is a contact force? Friction?
It should be friction.
It should be friction. Okay. Question third, 4 children were asked to arrange forces due to rolling, static, and sliding frictions in a decreasing order. The correct arrangement is rolling, static, sliding, rolling, sliding, static. Option C, static, sliding, rolling.
See, it's decreasing. So first of all, we go with static when an object is not moving. Then we go on sliding when we push the object, and it's when we slide the object, it requires a lot of force, but it's a medium one. And the rolling friction is done by bearings, or you can just put pencils below a duster and move it and just keep changing the pencils, and that can do the job. But here's an example. Look, it's a static friction. Now I got the table upside down. See, sliding friction is more than the, you can say, here is the static friction. So static friction is that much. I showed you the rolling friction, and now let's check out the sliding friction. The sliding friction is like this. It acquires force, but if we check on the rolling friction, it acquires very tiny amount of force to move an object. So we take it as static. greater than sliding is greater than rolling. Um, so there you go, the decreasing order of frictions.
Okay. Now the fourth question is, a big wooden box is being pushed on the ground from east to west. The force of direction due to ground will act on this box towards north direction, south direction,
We are applying force on the box
from east to west.
from east to west. So the box will move in west. Just to take a peek for let me place two markers for it. So here's the blue and red markers. Imagine this as east and this as west. So we are moving it from east to west. So the box is moving in west direction. See that it's moving in west direction.
The question was, you didn't answer the answer of the
So
question.
wait, it's going to west direction.
It's going to west direction, but he is asking the force of the direction, the force of the friction due to
It's going.
ground will
It's
act on this box towards.
Okay. Let's imagine the chair again.
Tell only on whiteboard. Only on whiteboard.
Wait. Let me check it. So we are applying from east to west. It's moving in west direction, but the friction is opposing our force in east direction. So when we try to push an object, we are applying the force to the west direction, but the friction is trying to stop it, the movement of the object, you say, to east direction. It's applying the force.
Okay.
So let
Got
me
it.
be on white.
Got it. Question 5. The friction between two surfaces does not depend on one of the following.
Okay, tell me the
Uh,
options.
One option is wrong and three options are correct. Yes. Amount of surface area of the two objects which is in contact with each other. Weight of the object which needs to move on the surface of the other object.
I think it should be the area of the object. It doesn't depend on friction, because no matter the area, the friction, blah blah.
Question 6. If the sliding friction between two surfaces is found to be 8 Newton, then the static friction between these two surfaces is most likely to be.
10 Newton.
How did you calculate friction between these two surfaces is most likely to be?
See, it was 8 Newtons.
Yes.
And it's the sliding friction. It's asking static friction.
Hmm.
It was most likely to be 10 Newton, because if it were to be 9 Newton, then they technically both would be the same. So let's take assure that sliding of it is so small, so the static of it must be 2 Newtons ahead.
Okay. Which of the following is not an advantage of friction?
Yeah.
Three are the advantage.
I know. Heat caused by friction damages the machines. That's not an advantage.
Yes. The option A, it enables drawing to be made on paper.
That's an advantage.
Advantage. Option B, it enables fallen things to be picked up.
Yeah, it has an advantage on that.
It enables rubber pads to be rubbed off.
That's a disadvantage, because see, this is a truck's wheel or something else. It's more likely to be like this when you buy it, full of friction to move on the road. But that frictions also cause to wear out all the rubber, thus resulting of a very smooth and flat rubber around it. And that's a disadvantage, because Low friction means the truck or bus will now slip, and it requires a lot of energy and lot of weight to push through.
Okay. Question 8. Which of the following statements is incorrect? 3 statements are correct and 1 is
I
incorrect.
know the drill.
I see.
Just
Static friction is greater than the rolling friction. Is it?
yeah, true.
True. Uh, rolling friction is less than the static friction.
Rolling friction can't be greater than a static friction.
Okay, okay. Option D. Static friction is greater than the sliding friction.
That's correct.
Correct. Option B. Sliding friction is less than the rolling friction.
Sliding friction is no less.
Sliding friction is more than the rolling friction.
Yes, it's incorrect. Static friction is greater than sliding friction. That's correct.
Okay. So the answer is B. Which
B.
of the following does not have a streamlined shape? Streamlined shape. Aeroplane. Does it have a streamlined shape?
Yeah, because if
No,
just
no need to explain.
because let me just give an example. This is an aeroplane. If it were to be like an aeroplane's nozzle were to be like this, then it wouldn't move. But still, an aeroplane's nozzle is more like this. Right over here, it's streamlined. That means air friction is less on it. But if we try a more broader shape like this, then it will not resist the air and thus causing a lot of air friction, may hitting the vehicle or stopping it mid-air.
Okay. Streamlined shape. I am asking you which of the following does not have a streamlined shape? Aeroplane, boat, bird, bus.
Bus doesn't has a streamlined shape.
Okay. So at bus there is more friction of air.
But the bus doesn't care, it doesn't move at high speeds.
Okay. Ball bearing is a device which usually converts
It converts
rolling
sliding
friction. There are 4 options. Please tell.
Sliding friction into rolling friction.
Okay, you have given answer. Fill in the blanks. There are some questions for filling the blanks. Force could be a blank or a blank.
Push or pull.
Okay. Friction is a blank force.
Opposing force. It's a contact force.
Yes, it's a contact force. Friction always opposes blank between the surface in contact with each other.
A movement.
Friction always opposes
The
force
force.
applied
Force applied.
between the surfaces in contact with each other. Number 4, sliding friction is blank than the static friction.
It's lesser than the static friction.
Okay. Shapes are designed to reduce air resistance are called blank shapes.
I think they are called streamlined.
Yes, streamlined shapes.
We just talked about them right
Yes,
now.
Question 6. Magnetic force is a blank force.
Non-contact.
Yes, it's non-contact force.
Because just imagine this is a magnet. It can pull an iron nail right from here like that.
It is contactless force, non-contact force.
Non-contact.
Question 7. Here is question 7 for you.
How many fill in the blanks are there?
Yeah, two more are left.
Okay.
Friction force is an example of forces. Blank forces.
Contact?
Yes, it's contact. You are right. Friction. Question number 8. Friction opposes the blank of a moving object.
Movement.
Friction opposes the blank of a moving object. Friction opposes the of a moving object.
Force?
Yes.
Force?
Yes, it's force. Now some more questions are here. Write T for true and F for false statement. You have to tell true or false.
Okay.
Okay. Only one line statements are there, and you have to tell about these statements whether it is false or true. Okay. Statement 1. Force can change the shape of an object.
True.
It's true. O- Statement 2. Force can make an object disappear.
No, never,
Oh.
ever. But you can make it disappear in a sci-fi movie.
Yeah. It cannot disappear an object.
But gravitational force, generally black holes gravitational force can make anything disappear out of nothing.
That's another thing.
Yeah,
Option-
it's another thing, but surely it can disappear the heck out of it.
Question 3. A push or pull acting on an object is called force.
Yeah. What?
A push or pull acting on an object is called force. Is it true or false? True. Statement 4. Force can change the direction of a moving object.
Force can change the direction of a moving object. That's true.
True. Statement 5. Friction always acts in the same direction as the motion.
Friction acts the
In the same direction.
it opposes it. So
Yes.
it's a false.
False. False statement.
Okay.
Statement 6. Frictional force depends on the types of surfaces in contact.
Yes.
It's
I
true.
gave an example, but I didn't explain it. Like if it was on a ice, I gave the example, but I didn't explain it on the whiteboard. See, if let us say another like metal or something, if we push it, then it the friction is less and it would go very far. But let's just imagine brittle wood. This is brittle wood. Okay, so now here comes the tough part, just aligning it with this.
Be aside while explaining your.
Okay, so this, if it will apply a lot of friction and seriously, it will be very hard to move it.
Okay. Yes. Question 7. Statement 7. Friction does not act on a bird flying in air.
Friction does act on a bird flying in air, but it's very, very little.
It's true or false?
It's actually true because if a bird is actually flying, then in mid-air, like in mid-air, it also gets some sort of air friction that does affect the bird, but it's made in a way like so that it has hollow bones, it has a streamlined shape, you can see, and it can like soar through the sky like a jet plane.
Friction does not act on a bird flying in the air.
It's
Friction acts on a bird.
absolutely, I give it false.
Fraction act on a bird. It is false.
Yeah.
Statement 8. Static friction is less than the sliding friction.
Static friction is
Is less than
not less than the sliding friction.
So it is true or false?
It's absolutely false. Is it done?
Yes.